Hello, dear students. As we are trying to build the concept of application, session by session we are progressing. Now, during this session, I am going to teach you about the solving of problems to calculate Coulomb's force using vector form. The theoretical concept already you have studied. The theoretical concept says, you say Coulomb's law in vector form. Now, what this says, Coulomb's law is used to calculate force on a point charge due to another point charge. So, let us assume one point charge is at this point, another point charge, say this is at this point. Let me name it. This is Q1, this is Q2. This is x axis for me, this is y axis for me, this is origin. The position at which the charge Q1 is placed is assumed to have a position vector of R1. The charge Q2 has a position on the xy plane. This position with respect to the origin is assumed to have a position vector R2. And the separation between the charges Q1 and Q2 is assumed to be vector R. Now, what I want to calculate? I want to calculate the force acting on charge 2 due to 1, and this is, since Q2 is positive, Q1 is positive, then Q2 will experience a repulsive force in this direction, and mathematically we write it as force experienced by charge 2 due to 1 is in this direction. This is what I want to calculate. Now, we are talking about vector form. So, the Coulomb's law in vector form is given by the expression like this: F21 is equal to K or 1 by 4 pi epsilon naught into Q1 into Q2 divided by R square. That is the magnitude of square. Since this is a vector quantity, this gives me the magnitude, and therefore I see that the unit vector pointing along Q1 to Q2, unit vector that points in this direction and the direction of F21 both are same, I am going to write it at unit vector R. When I say unit vector R, then this expression can also be written as F21 is equal to K into the product of the two charges into. Instead of writing this unit vector, I can write it as vector divided by its magnitude. When I divide by magnitude, this magnitude into square of magnitude will be magnitude cube, and here at the numerator I am going to have vector. So therefore, I am going to write R vector into or divided by cube of magnitude, and this is the expression that you have studied earlier. I am going to use this expression. Sir, already we have studied Coulomb's law. Again, we are trying to talk about Coulomb's law in vector form. So what is the advantage of having this one? Previously, when we solved problems, there we calculated magnitude separately and we used to write the directions separately. But here, when we use this expression, we are going to get magnitude as well as direction while solving the problem directly. Okay, in that case, two important things that we need to take into account while employing this formula for solving to find Coulomb force. In that case, what is the first thing? The very first thing that we need to pay attention is Q1 into Q2 are the 2 point charges. While solving the problem, we will be substituting the value of the charges. While substituting, we will substitute the value of the charge with sign, whether it is positive charge or whether it is negative charge. So therefore, substitute the values of Q1 and Q2 with sign. If it is positive charge, I am going to substitute with plus value. If the charge is negative, I am going to substitute negative value, minus of that value. The second important thing that we need to take into account is, while calculating the force on any particular charge, this vector, relative position vector, this will have its direction, head, that is arrowhead. The arrowhead will point on the charge at which the Coulomb force is being calculated. This is the second concept that we need to take into account. I said, while using this problem, we will substitute the value of the charges with sign. Second thing, R vector. R vector is nothing but the relative position of charge Q2 with respect to Q1. So therefore, this is a vector. So vector will have one tail and head. So where the head must be placed, the head of the vector must be placed at the charge at which we are calculating Coulomb force. These are the two important concepts. If you remember, then we can solve the problem. That is, place the head of vector R at the charge in which Coulomb force is being calculated. But these are the two important notes or points that we must keep in mind to solve the problem. So let us move on to the problem. Let me say that I have 2 point charges. One is 5 microcoulomb and other one is minus 5 microcoulomb, or rather let us say 5 coulomb and minus 5 coulomb. Okay. So let me suppose that I have a charge Q1 of magnitude 5 coulomb, which is very, very large, and let me assume that I have placed this one at position 7, 10, say, and the other charge Q2 I have placed Q2 of minus 5 microcoulomb I have placed at say 4, 3, 9, 4, say 6. These are the 2 charges, and I want to calculate what is the force experienced by the charge Q1 due to Q2. So let me place the charge on the plane. So this is the case. Let this be the origin. Let this be x-axis, this be y-axis, and the charge Q1 is placed at 7i plus 10j. So this is 7i 10j somewhere here. This is my positive charge. So this is 5 coulomb for me. Let me say this is position B, and this has a position vector of this one, and let me say this is R1 for me. And the second charge, minus 5 coulomb, is placed at 4, 6. So somewhere 4, 6 here. So this is charge minus 5 coulomb. Say this is Q2 for me. This is Q1. And this charge has a position vector of say R2. And I want to calculate. So is it right? I hope 4, 6, 7, 10. Yes. And say this is R1. Let me write here to make the picture more clear. And I want to calculate, so be mindful of this one is negative charge, and this is the relative position between the 2 charges. And to calculate the force on 5 coulomb charge using vector form, I said the relative position vector head will be placed on the charge at which we calculate the force. This will be, say this is R. Say this is R. So we need to calculate what is R. So from vector diagram, we know that R plus R2, these two vectors are in same order. This will be equal to R1. As such, R is equal to R1 minus R2. R1 minus R2. So we need to calculate the force on this charge. So if I look at, this is plus charge, this is minus charge. So the force is going to be in this direction. So force on second charge due to first charge, or this is first charge. So force on first charge due to second. So now the expression I can have force on first charge due to second charge. This is equal to K into the product of the two charges, Q1 into Q2 by cube of the magnitude. So let me say cube of the magnitude into this vector. Now I want to calculate what is R. To calculate R, I must know R1 and R2. To know what is R1, I need its coordinate, this point's coordinate. And R1 coordinate has 7 cos. From here, R1 is equal to, the coordinate is 7, 10. So this is 7 I cap plus 10 j cap. And about R2, this is equal to 4 I cap plus 6 j cap. Now I can calculate what is R. So to calculate R will be equal to R1 minus R2. So 7 I cap plus 10 j cap minus 4 I cap plus 6 j cap. And this was 7 minus 4. This is 3 I cap. 3 I cap. 10 minus 6 is 4 j cap. And I got the vector R. I want what is its magnitude. So magnitude of R is equal to root under 3 square plus 4 square, which works out to be root under 25, and this is 5. Let us assume that the positions are measured in terms of meter. Now let us substitute the value. We know this is the expression, and we already noted the point while solving or calculating the force using vector form. We will substitute the value of charge with the sign. So therefore, F12, force on the first charge due to 2, is equal to the value of K. I am not going to substitute. Let me keep K itself because I know the value Q1 and Q2. So Q1 for me is plus 5 and Q2 is minus 5. So therefore, plus 5 into minus 5, Q1 into Q2, into vector R I have already calculated. So this happens to be 3 I cap plus 4 j cap divided by cube of the magnitude of distance, which is 5q. And this works out to be F12 is equal to 5 into 5, 25. So minus K, 2 5 goes off. So K by 5 into 3 I cap plus 4 j cap Newton. So this is the force experienced by the charge plus 5 Coulomb due to this minus 5 Coulomb charge. The next problem is, let us assume that we have a cube of side 1 meter, and at each of the vertex of the cube similar charge q is placed, and let us try to find the Coulomb force at any one of the charge in one of the vertex due to all other charges in the cube. Let us see. Here let us suppose that we have a cube of side 1 meter and I say that at each of the vertex charge q is placed, and I want to calculate what is the Coulomb force at any one of the charge. So let me say I want to find what is the force experienced by the charge placed at this vertex. So to solve this problem, I am going to use Coulomb's law in vector form, because this is the easiest approach to solve this problem using vector form. When we use vector form, we will find that we can get the solution more easier way. For that purpose, what I am going to do is, let me name the vertex. It will become easier for me. So let me name this as 1, 2, let me say this is 3, 4, say 5, this is 6, 7 and 8. 8 vertex. And I have to assume the origin also. So to assume the origin, let me assume the origin at the vertex 1. I can assume the origin anywhere I like. So for me, I find this will be the easiest one, and therefore this axis will be x-axis for me, and this axis will be y-axis for me, and this will be z-axis for me. I said each side of the cube is 1 meter, and I have to find what is the force here. So now what I need to do is, I need to calculate simply what is the force on charge 6 due to 1, what is the force on charge 6 due to second charge, what is the force on charge 6 due to third charge, what is the force on 6 due to fourth charge, what is the force on sixth charge due to fifth charge, and what is the force on sixth charge due to sixth due to seventh charge, and what is the force on sixth due to eighth charge. So altogether, I am trying to calculate what is the force experienced by charge at 6 due to other charges. So other charges are 7 charges I have. So therefore, I am going to get 7 forces, 1, 2, 3, 4, 5, 6, 7. So to solve this, what I am going to assume is, I am going to assume the coordinates, and the coordinates will be here. See, 0, 0, 0. And this is along x-axis. So vertex 2 will have 1, 0, 0. This 3 is lying on the xz plane. So this will be xz. So 1, 0, 1. Fourth is lying along z axis. So this must be 0, 0, 1. How about 5? 5 is lying on yz plane. So x is 0. So 0, 1, 1. This sixth point is lying in space. So this will have a coordinate 1, 1, 1. This seventh vertex is lying on yxy plane. So this will have x, y and z. And this eighth point is lying along x-axis. So I hope you understand, this will have 0, 1, 0. So these are the coordinates of all the vertices. If that is the case, I want to find now what is the force on sixth charge due to first charge. So when you say first charge, I hope you understand, you have studied the distance between this vertex and this vertex, diagonal of the cube. This will be √3 times of the side. So therefore, this will be equal to k into the product of the two charges. This is q and this is q. So q square, and see the magnitude of the distance. So this side is 1 meter. So root 3 times 1. So this will be root 3 whole cube into vector. I have to write. So what is the vector then? See, if I said the thing that we need to keep in mind, how we are going to draw the relative position vector. The head will be placed at the charge on which the force is being calculated. So therefore from this point I am going to draw the vector up to this point, and the vector head will be lying here at this point. So R2 minus R1. So 1 minus 0, 1 minus 0, 1 minus 0 this will have. So if this is 1, 1, 1, do you think that the position vector of this is I, j, k? And the position vector of this is 0, I, 0, j, 0, k? So if I subtract, so do you think that I am going to get, see, 1i minus 0i. So I am going to get 1i. So this will be I. 1j minus 0j. So I am going to get 1j. 1k minus 0k. I am going to get 1k, which is equal to this. I plus j plus k. Magnitude of this vector is root under 1 square plus 1 square plus 1 square is root 3, and that is what we got. Next force is F6(2). So 6 is this charge, 2 is this charge, and this distance. Let us try to calculate now. See, this force. So this will be equal to k into the product of the two charges. Q into q is q square into vector. When I talk about vector, so see the final arrowhead will be here. So this is the final vector I plus j plus k, and this has only I vector. So from here, if I try to calculate, so see please, this minus this will be 0. I will have j plus k. I hope you understand now. J plus k. Because 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 0 is 0, 1. So in that case, see, j minus 0, j, and k minus 0 is k. I minus I is 0, so therefore there is no I. Divided by magnitude of this is root under 1 square plus 1 square is root 2. So therefore root 2, this will be whole cube. How about this one? Force on 6 charge due to third one. So this must be k into product of the two charges. So q square by, okay, vector let us write. So therefore arrowhead will be like this. So here I minus I is 0. I minus I is 0. So j minus 0 is I am going to get j cap, and 1 minus 1 is 0. So therefore I am going to have only j cap, and when I try to calculate magnitude, I am going to have 1 cube. 6, 4. So sixth one due to fourth one. This k, I hope you can understand now. Q square, I am going to have the vector. So to see the vector, this 1 minus 0, 1. So therefore I cap. 1 minus 0, j cap, and 1 minus 1 is 0. So this, and when I try to find the magnitude, this will be root 2, and this is q. It's easy now to calculate what is the force on the sixth charge due to fifth charge. And the fifth charge is this. This is sixth charge, and this will be k into q square. When you talk about vector, 1 minus 0 is 1, so I cap. 1 minus 1 is 0, 1 minus 1 is 0, so I cap divided by 1 q. 6, 7. So sixth charge is this one, seventh is this one, so you will have k q square into, when I talk about vector, see please, this is the charge at which I am trying to calculate the force, and therefore for me this is 1 minus 1, 0, 1 minus 1, 0, 1 minus 0 is 1. So therefore, I am left with only k. So therefore, k cap divided by 1 square. And force on this charge 6th due to 8th charge, 6th due to 8th charge, this will be k q square into, when I talk about vector here, 1 minus 0 is 1, so I cap, 1 minus 1 is 0, 1 minus 0 is 1 plus k cap divided by magnitude of this vector is root 2 whole cube. This is cube. So I have calculated all the 7 forces that the charge placed at the 6th vertex will experience, and I want to find the net force. So the net force is very simple. F net force will be the vector sum of all the forces. 6 2, 6 3, 6 4, 6 5, 6 7 and 6 8. So the F net is equal to F61 we calculated. So I can take k q square, I hope common from all, and I have the first part F61, I will have I cap plus j cap plus k cap by 3 root 3. If I take the second one, I will have j cap plus k cap by 2 root 2 plus I will have j cap by 1 plus I cap plus j cap by 2 root 2 plus I cap by 1 plus k cap by 1 plus I cap plus k cap by 2 root 2. Now, to calculate the F net, further we can separate. See, I cap and I cap. We can sum it separately. Similarly, we can sum the coefficient of the similar components, and we can express the kq square into, we are going to get some magnitude I cap plus j cap plus some magnitude k cap, and this is the final answer for the force experienced by the 6th charge, and this is the task for you that you need to calculate using these values. Thank you. In the coming session, we shall come up with some other problems based on some other concept. Thank you very much.